Hello and welcome to Physics Friend, Physics Friend, Physics Friend. This video is about heat transfer. We're going to talk about conduction, convection and radiation. These are all methods of heat transfer and they all work in a slightly different way. We're going to talk first about conduction. Conduction occurs a lot in metals or something where the particles are very densely packed together. You don't really get conduction in air because the particles are so spread out in air that they're not close enough to affect one another. You get a different kind of heat transfer in air and other liquids, which we'll talk about later. So conduction is the most prominent method of heat transfer in solids, and particularly metals. Some metals are better conductors than other. Copper is a very, very good conductor. Aluminium, for example, isn't such a great conductor of heat. Now, what happens in conduction is very simple. I heat one part of the metal. So one part of the metal is very hot and the other part is not hot because it's not being heated. The parts of the metal which are being heated start to vibrate slightly, they start to shake from side to side. If we heat up an object, if we heat up something like a rod of metal, the particles inside that rod of metal start to vibrate from side to side. Now if I'm here as one particle, another particle is here as another particle, and I've got someone here wobbling a bit, I'm going to start to shake as well. So I'm going to start to vibrate too. What happens is that as time goes on, you get all these particles transferring their vibrations, they're transferring their kinetic energy, between one another in order to move heat from this hot place to the cold place. Like I said, heat is, the universe is just orientated in such a way that heat flows from something hot to something cold. It always flows from hot to cold. So if I've got a hot part of a metal here, it's going to transfer its kinetic energy in its particles as heat down from one end to the other. And that's all conduction is. It occurs in saucepans when you're heating up a pan. That's how the heat comes from your gas or your hot plate into the food. It conducts through the pan. Convection. So convection is, again, it's a method of heat transfer. It's how heat is transferred. Rather than each particle affecting its neighbouring particle in convection, what happens is the actual particles themselves, they migrate, they move to a different part of the room. If I have a radiator in the corner of the room, for example, it'll heat up the air around it, probably through a mixture of conduction and a little bit of radiation, but it'll heat up that air immediately kind of surrounding that radiator. And as things get hot, guess what? They expand. As they expand, they become less dense. As they become less dense, they then rise. That's what happens. We know this anyway. So what happens is that you get the hot air expanding and rising. Now, as that hot air rises, the cold air is going to sink down and take its place, and that'll get heated in turn. So we get this convection current. All it is hot air rising, cool air sinking. Hot air rising, cool air sinking. Hot air rising, cool air sinking. And you get this kind of convection effect. So convection, rather than like in conduction, it's not affecting the particles immediately neighbouring it. The actual particles themselves are moving around. Same thing you get in water. If you heat water in one particular end, that water that's being heated is going to heat up, rise, it's going to cool at the top, and then the cool water of the other side is going to sink down. You're going to get a convection current. So all you've got, again, is you've got heat being transferred from hot things to cold things. Radiation. Radiation is slightly different because you know what the interesting thing about radiation is that we don't even need any particles in order to transfer heat by radiation. Radiation is given off by anything that's hot. It doesn't even require a medium to travel through. So it's actually quite hot here, to be honest, and I'm radiating heat, as are the lights, as is the sun outside. I mean, everything is radiating up to some extent. The hotter it is, the more it is radiating. Now, with radiation, the heat transfer is almost immediate. It travels at the speed of light. A good way of thinking of this is if you've ever been near like a firework display and there's a big flash of flame, like one of these pyrotechnic bursts of flame, you look at the flame, you see the flame, and immediately you like feel this wave of heat. That is the radiation, the infrared radiation, just hitting you. It's beaming its electromagnetic radiation at you in the form of infrared waves, basically. a good way to kind of think of this, which is something which I didn't really discover till fairly recently, I used to think about open fires when you have a house and you've got like a wood fire in the corner, that so much of that heat is just totally wasted because it all just goes into the air and just goes up the chimney. And that's true, a lot of heat is wasted. But the majority of heat gained from an open fire is actually through the radiation which is being emitted by that fire. Imagine that fire is just this really bright light. It's just like this beaming light, a bit like the sun, but with less visible light. So lots of light, but we can't see it. Now that light I'm talking to, is infrared radiation. It's beaming out radiation at such a great rate that you can feel it on your skin, but you can't really see it with your eyes. Our eyes can't see infrared radiation. We can only detect this very, very narrow part of the spectrum, which is called visible light. So radiation doesn't require a medium. It doesn't require any particles to travel through. It travels very quickly and it's given off by anything which is hot. The hotter something is, the more radiation it gives off, the more it radiates heat. Things that are hot like to cool down to their surrounding environment. It's just the way the world is. It's the language that the universe speaks in. It's something which is the same across the entire universe. Everything is cooling down. It's giving its heat away. Very generous. All the hot stars out there, they're just giving all their heat away to the cooler planets like us. If it wasn't for the sun, we'd be pretty cold right now. And some theories suggest that in millions of years, hundreds of millions of years, the entire universe will cool to a very cool 4 degrees Kelvin, which by the way is minus 269 degrees Celsius, which is like, you can't live in that cold. I hope that's useful. We've covered all 3 main types of heat transfer there. I think I've covered everything. If I haven't, do this with your mouse, go down, right in the box, blah, 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 you suck, you forgot this, you didn't even talk about this, you didn't mention that. Well, if I didn't, then put it there. I'll put some clarification, and if you've got any questions, just write them there. This is Physics Friend, videos there, and you can subscribe there. Thanks for watching, I'll see you again next time.